Hello friends, I welcome you in lecture number 13 on Laplace transform. In this lecture we will discuss one new formula for finding Laplace transform. We are familiar with multiplication by t raised to n. We know that if our function is multiplied by t raised to n, where n is a natural number, then Laplace transform of t raised to n times f of t is given by n times derivative with respect to s of Laplace transform of f of t. Now suppose our function f of t is divided by power of t. Suppose f of t is divided by say t. Then how to find out Laplace transform? So for that we have ready-made formula. If our function f of t is divided by t, then Laplace transform of f of t divided by t is given by integral of Laplace transform of f of t with respect to s from s to infinity. Or suppose Laplace transform of f of t is denoted by capital F of s, then we will write in this way: integral of capital F of s from s to infinity, where f of s is Laplace transform of f of t, and this is improper integral of first type because upper limit is infinite. So we know how to evaluate improper integrals. So first I have written this formula. We will remember this formula as division by t. If Laplace transform of f of t is capital F of s, then Laplace transform of f of t divided by t is given by integral of f of s with respect to s from s to infinity. Or we can remember in this way also: we have to integrate Laplace transform of f of t with respect to s from s to infinity. We discuss one example of this type. Find the Laplace transform of 2 divided by t times 1 minus cos omega t. This we can rewrite as 2 times 1 minus cos omega t divided by t. So first we find out Laplace transform of 2 times 1 minus cos omega t. If we compare with f of t divided by t, then f of t here is 2 times 1 minus cos omega t. So for this formula, first we require Laplace transform of f of t. So first we write down Laplace transform of 2 times 1 minus cos omega t, and this is by linearity property. 2 times Laplace transform of 1 minus cos omega t, and again by linearity property, this is Laplace transform of 1 minus Laplace transform of cos omega t. We have ready-made formulas for both the Laplace transforms. We know that Laplace transform of 1 is 1 divided by s. Laplace transform of cos function is s divided by s square plus square of coefficient of t, which is omega square here. So this is Laplace transform of 2 times 1 minus cos omega t, and now we use that formula division by t, and here we write that this is Laplace transform of 2 times 1 minus cos omega t. Now we are interested in the Laplace transform of 2 times 1 minus cos omega t divided by t, and using that formula for division by t, we write this as integral of Laplace transform of 2 times 1 minus cos omega t. Integral is with respect to s, and this Laplace transform we have obtained. So we now write down value of this Laplace transform. It is 2 times 1 divided by s minus s divided by s square plus omega square. Integral is with respect to s. Now this is again written by multiplying this bracket by 2. So we write 2 by s minus 2s divided by s square plus omega square. Integral is with respect to s. Now this we can rewrite as limit. Suppose we consider upper limit as b, then this is limit as b tending to infinity from s to b, integral of 2 by s minus 2s divided by s square plus omega square. We know that here upper limit is infinite, so this is improper integral of first type. And to evaluate this improper integral, first we find out integral from s to b, and then we will consider limit of this integral as b to infinity. Now we know these formulas of integral. Integral of 1 by s is 2 times log s minus integral of this function 2s divided by s square plus omega square is if we observe that derivative of s square plus omega square is 2s. So here I can rewrite this as d by ds of s square plus omega square divided by s square plus omega square, and formula for this is log of s square plus omega square. So here we write log of s square plus omega square, and limits are from s to b. Lower limit is s, upper limit is b. Now we try to simplify this function which is written in the bracket. Then we will put limit. So this we can rewrite as log of s square. Using the property of logarithm, this we can rewrite as log of s square minus log of s square plus omega square. Limits are from s to b. Again, using the property of logarithm, we can rewrite this bracket as log of s square divided by s square plus omega square. Limits are from s to b. So first we consider upper limit, and then lower limit is s itself. So for upper limit we will put s equal to b, and we have log of b square divided by b square plus omega square minus lower limit as it is s square divided by s square plus omega square, and we write in the bracket. So this is upper limit minus lower limit. So now we have to find out limit of this bracket. So limit of log of b square over b square plus omega square can be written as log of limit b tending to infinity b square divided by b square plus omega square, and minus limit of this function log of s square divided by s square plus omega square, which is independent of b. Therefore its limit is function itself, s square divided by s square plus omega square, because this is independent of b. So limit of this second function is that function itself, because it is independent of b. Now how to find out this limit? So we can observe that if we take b tending to infinity, we will have infinity by infinity form. So we can apply L'Hospital rule. Limit b tending to infinity, we differentiate with respect to b. Derivative of b square is 2b, here also derivative of b square is 2b, derivative of omega square with respect to b is 0, and this is minus log s square divided by s square plus omega square. So we keep this as it is. Now here 2b will cancel out, and we will have log of limit of 1 as b tending to infinity minus log of s square divided by s square plus omega square. Limit of 1 is 1, so we have logarithm of 1 minus log of s square divided by s square plus omega square, and because this is natural logarithm, log 1 is 0, and finally we have log of s square divided by s square plus omega square. And using the property of logarithm, I can rewrite this as, I can take this minus 1 in the power of s square divided by s square plus omega square using property of logarithm, and this we can rewrite as, because we have negative power, we will have s square plus omega square divided by s square, and again we can rewrite this as log of 1 plus omega square divided by s square. So finally this is our Laplace transform of 2 by t 1 minus cos omega t, and this we have obtained using that formula for division of f of t by t. Laplace transform of f of t divided by t is given by integral from s to infinity Laplace transform of f of t integration with respect to s. And to find out this limit, we have used L'Hospital rule here, so we mention in the bracket that by L'Hospital rule, because we have infinity by infinity form in this limit. Now if we don't want to use L'Hospital rule, we can find out limit without using L'Hospital rule also. For that we divide numerator and denominator by b square. So if I divide this b square by b square, I will have 1, and if I divide b square plus omega square by b square, then I will have 1 plus omega square divided by b square. So we have divided numerator and denominator by b square, and we obtain this. Now if we take b tending to infinity, we will have 1 plus omega square over infinity, so that is 0, and we will directly obtain 1, and then log of 1 is 0. So either you can go in this way for finding this limit, or you can apply L'Hospital rule. So in this way, if our function is divided by t, then we can find out Laplace transform of that type of function. So for that we have to write our function in this form, function of t divided by t. Then we will find out Laplace transform of that function f of t. So first we obtain Laplace transform of this function, and then Laplace transform of this function divided by t is equal to integral of Laplace transform of this function with respect to s. And while integrating, we have logarithmic function here. So we have used properties of logarithm. First we take we use this property, m log n equal to log of n raised to m. That property we have used here, and we have used this property also, log of m by n is log m minus log n. So that property we have used here, and then using this L'Hospital rule, we are able to decide this limit, and that limit turns out to be 1 and log 1 is 0. So we obtain this as Laplace transform. Laplace transform is log of 1 plus omega square divided by s square. So in this way we can find out Laplace transform of a function f of t which is divided by t. So for that, first we have to decide that what is our f of t, then we find out Laplace transform of f of t, and then we integrate it with respect to s from s to infinity. So this is all about this session. I hope you like it. In upcoming lectures we will discuss some more problems of this type. Thank you very much.